So it's 13.3 exercise. So there is a cylinder. This is big cylinder. You have to take a big one. Okay, and inside this cylinder, a cone on which inside this one there is a hemisphere. Inside this one there is a hemisphere, and this is a hemisphere. Okay, and on this hemisphere, a cone is mounted on this hemisphere. Yes, this is the given question. Now, what we have given, just we will write the dimensions given is the height of this bigger one cylinder. This one cylinder's height is given us, and radius 60 centimeters radius of the cylinder. You can write this radius of the cylinder, and radius of this hemisphere is given, and actually this is touching 60 centimeters, same radius. We should make it big, hmm, because they have same radius. So in this figure, actually, we have to make, yes, bottom of the cylinder, and yes, yes. So this should touch the bottom, and actually this cylinder. Okay, I, no problem, no problem. I will do it. This should touch the, because of it will not show touching, so I am putting like this only. It should be like this, okay? And this line keep coming from here, and you can make it big, and this line comes here. Now it is touching. Now it is touching. Okay. Now this is given 60 centimeters. It is 60 centimeters, and height is 120 centimeters. 120 centimeters, and this radius, and it is touching the base, and this is also 60 centimeters. And what else is given? Standing on a hemisphere of 60 centimeters radius, is upright, full of water such that it touches the bottom. Find the volume of water left in the cylinder if the radius of the cylinder and its height is 180 centimeters. So 120, 60, 60 both same, and 120, a solid consists of a right circular cone of height. So height of the cone is also given us. This is the height of the cone. But cone is also touching above if its height is 120 centimeter. A solid consists of right circular cone of height 120 centimeters. Oh, okay, okay. This 120 centimeter is the height of this part. This from here to bottom, and outside this is outer height is more. This is not 120. This is given us 180 centimeters. 180 centimeters. This is 180 centimeters, and this height, total height is 120 centimeters. Okay, and radius of both are same. So it is placed inside. So how much? Find the volume of water left in the cylinder if the radius of the cylinder is this and this. So how much water is left in the cylinder? The total volume of cylinder minus volume of this solid placed inside. So volume, here we are taking, suppose this is capital R, although both R are same, and this is we are taking a small r, and its height we have to find out. This height h, this is suppose h. So this height h is equal to, we will find the height h is equal to, what will be h? 180 is the total height. This is 180. No, sorry, 120. In 120, from 120 you can subtract the radius, because from here to here it is 120, and this is the radius of hemisphere. So 120 minus 60, 120 120 centimeter minus 60 centimeters. So 60 centimeters is the height of the cone, and radius of the cone is also 60 centimeters, and this is the height of the cylinder capital H. Now we can find the volume of water left in the cylinder. The volume of water left left in the cylinder will be equal to the volume of cylinder and minus volume of, you can write in bracket, volume of cone plus volume of hemisphere. Volume of cone and volume of hemisphere. Okay. Now let's put the values here. Volume of cylinder. Cylinder's volume is pi r square h. So capital R we are taking. So put the formula first, pi r square h minus volume of cone is 1 by 3 pi, small r we are taking, small r square h, although they are same, plus radius is same, we can take the same radius. So small r and capital R are same, so we can take same radius, but height is different. Volume of hemisphere 2 by 3 pi r cube. Now substitute the values. Pi r square, take same r actually, otherwise we cannot take common. So replace this r by small r only, r square, and this is also r. I have it written here. So pi r square we can take common, pi r square. So h minus h by 3 plus 2 by 3 pi r square is taken common, pi r is left. Now substitute the values. So 22 upon 7 into r square. Radius is 60, so 60 into 60 multiplied by capital H is 180 centimeters minus small h 60 by 3 plus 2 by 3 into radius. Radius is 60. So this will be 22 by 7 into 60 into 60 into
Sir,
3. Yes,
you said here the height of cone will be 120, right? I think you wrote 60. Yeah, 60 by 3. It should be 120 by 3 above. And the 180 minus 60 by 3, so it should be 180 minus 120 by 3 because height is 120.
He minus the height now. Is the above. 120 minus 60.
No, because
Yeah.
a solid consists of a right circular cone of height. Ah, yes, yes. Height,
sir, here, this,
such as not the
here, sir.
height of full one.
This should be, I think, 120, right? I don't know if you can see that.
Okay, replace this one. We can see that way whether we are getting answer or not. So then, okay, so h we have taken the height. So instead of this height, if we will put 120, okay. Now 180 minus 3 4 the 12, 40 plus 3 2 the 6, 2 3 to the 6, 2 to the 4, 40. So we get 22 by 7 into 60 into 60 into because of this minus we are multiplying inside this minus, huh? So this will become minus and this will also become minus. Minus 2 by 3 and this plus will be minus. So then this which is minus. So 180 minus 80, so it will become 100. Okay, now check the answer whether we are getting the answer or not. Just check it. 100 into 60 into 60 into 22 divided by 7. What is the answer behind? Check. Yes, we are getting correct answer. But in cubic centimeter, so it is very big answer in cubic centimeter. Now, so this one you have to make it small. This is the height of the cone. This is h. Okay, and height of the cone is taken 120 centimeters. That is not the height of the full solid. It is given that height of the cone. So that's why. Now we are getting the answer, very big answer in cubic centimeter. So if we convert into one one three one 428.571 cubic centimeters. And if you want to convert into cubic meter, so you have to divide it by 1131428.571 divided by 1 meter is equal to 100 centimeters. So cubic centimeters, 100 into 100 into 100. So 6 places. The decimal will shift to 6 places. 1, 2, 3, 4, 5, 6. So this decimal will come here after six places. It will shift. So this will become 1.131 cubic meter. Okay.
Yes, sir.
Last question you discuss now. So a spherical vessel of a cylindrical neck, 8 centimeter long, 2 centimeter diameter. The diameter of the spherical part is this. By measuring the amount of water it holds, it child find its volume to be cubic centimeter. This is right, cubic centimeter, and check whether she is correct. Taking above as the inside measurement, pi is equal to 3.14. Okay. So there is a cylind spherical vessel having neck as its neck is a spherical part, and its neck is cylindrical. Okay. So now we will do it fast. Uh, Diameter. This is 2 centimeter. This part from here. This is 2 centimeters diameter. This is 2 centimeter. Diameter of this cylindrical part, and the neck 8 centimeter has a cylindrical neck 8 centimeter long. This is up to here 8 centimeters. Okay, and 8 centimeters. Okay, now 8.5 centimeter is the radius diameter of the spherical part. That means this part from here to here, this part is given as 8.5 centimeters. So we have to find the volume. We have to find the volume of spherical vessel and check with this one. The volume of spherical vessel, spherical vessel will be equal to the volume. This will become half radius 1 centimeter, and its radius will also become half, and its radius is we are taking capital R. So now volume of this spherical vessel pi r square means upside pi r square 8 plus 4 by 3 spherical part 4 by 3 pi r cube. R is half of it is 4.25 whole cube. So when you solve it, just substitute the value of pi is 3.14. Your answer will be 346.51. So which is not matching with 345. Okay. So correct answer is this one. So the she finds a volume to be, check whether she is correct. No, she is not correct. He is wrong. Okay, got it. So this is the, that's all for this exercise. So you will get some extra questions, and next time we will